So we've had the opportunity to go over the vertical asymptotes, all the rules kind of with the horizontal asymptotes. There is another type of asymptote, and it's known as the slant asymptote. And back, if you recall from Algebra 2, we studied synthetic and long division, and the whole reason why we did that was so that we could actually start to graph slant asymptotes using that synthetic division or long division. I'm sorry, synthetic division. Now, this can only happen, though, when the degree of your polynomial on top is exactly 1 more than the degree on the bottom. So, for example, in example 6, we can see that we have this degree of 2 on top and the degree of 1 on the bottom. That's the scenario that we're discussing, when it's exactly 1 greater on top than it is bottom. And there's another stipulation that says that this guy on the bottom has to be at least a degree of 1. Like, you can't just have a constant that you're working with. Alright, so there has to be a variable in there on that bottom. And then also, kind of like with any remainder with this, it's not really seen as important, and we can kind of talk about why. But it does have to do with what we're going to be discussing in a little bit, dealing with limits. Now, if we go ahead and find the slant asymptote for this one, if you recall from synthetic division, all that you have to do is take this second guy, this x minus 3, take the opposite sign of him, throw him in a box, and then take the polynomial on top. Well, the coefficients are 1 and 2. Now, I left myself a little bit of a space here, and there's a reason why. If you think about it, there actually is an imaginary x here, and the coefficient for that x would happen to be 0. So if you're actually trying to do your synthetic division correctly, we do have to have that placement of the 0 in there. If you don't have that, that will actually throw your answer off. So make sure you don't forget those hidden ones. Then we just leave ourselves some space and then draw a bar. For synthetic division, it may be a while since you guys have seen this. The first one, you just drop that first number, you just drop down. Now the number in the box, we're going to go underneath our bar and multiply anything that's underneath our bar here. So 3 times 1 gives us 3, and we're just going to go ahead and place that right under the next number. In this case, it's 0. Then we're going to go ahead and add going down. So 0 plus 3 just comes out to be 3. And then you pretty much just repeat the exact same process over again. So we're going to multiply 3 times 3. That gives us 9. We're going to place it right under the next number. We're going to place that right under the next number. Now we have 2 plus 11. Again, you just keep adding going down. And that's 11. Now the reason why synthetic division actually works here again is because we have at least a degree on the bottom being 1, and the degree on top is only 1 larger than the one on the bottom. Now we've done our synthetic division, and we have a bunch of just like numbers here. Well, because we have this x squared, if we imagine for a moment x squared divided by x, well, you can kind of think about this as, if you recall back to your properties with exponents, really you're just removing an x variable. In other words, like, we can actually divide this x out, and really we're subtracting 1 from that exponent. The same thing is actually, and then as a result you would end up with x to the 1. The same thing is actually happening over here as well. Because we technically divided using synthetic division, instead of x squared now, we're removing it down by 1 exponent, so now it's going down to just x. Alright. Now this 3 happens to just be our constant, and it is in fact a positive 3. Because there's no negative in front of the 3. This 11, on the other hand, happens to come out to be our remainder. But again, we don't really care too much about the remainder. So as a result, our slant asymptote just comes out to be y is equal to x plus 3. So that is our slant asymptote for this first rational function. So again, it kind of just goes back to this idea that you have x squared, you're dividing it by x, so then that's why your slant asymptote now is just x to the 1, because you're removing one of those powers. Going over here to the second one, we see that we have a problem where the degree is just one more than the degree on the bottom. But unfortunately, because synthetic only works when we have a degree of 1, we can't use synthetic division. That's why in Algebra 2, though, we did study this other form known as the long division. So what we're going to do now is we have our polynomial. I'll give us some space. We have our polynomial 2x cubed minus 3x squared. We have no x's, but there really is a hidden one, and it just happens to have a coefficient of 0 in front. So we're going to go ahead and just insert that in there. So we have plus 0x, and then finally plus 5. Now instead of synthetic where we had the box, we're going to go ahead and do long division, much like you guys have seen in like grade school and your Algebra 2 classes. Now we are going to divide it by this x squared plus 4. And now we're just going to go ahead and ask ourselves, what times x squared gives you 2x cubed? Well, 2x would accomplish that, because 2 times 1 gives you 2. And then x squared times x gives us that x cubed. This 4 is along for the ride, so we're going to go ahead and multiply that 2x times that 4 as well. That gives us 8x. Now it's really important to put that right under where it belongs. Notice we're not going to put it under this x squared, we're going to place it right under this other x. Now by properties of long division, you always swap those signs. So they were positive before, now they're negatives. Our 2x cubes cancel out, that should happen. And then we end up with negative 3x squared. 0x minus 8x gives us negative 8x plus 5. And then you pretty much just repeat the exact same procedure. So what times x squared gives us negative 3x squared? Well, negative 3 does that. So then we end up with negative 3x squared. That 4 is along for the ride, so negative 3 times positive 4 comes out to be negative 12. Placing that right under our constant, our other constant that we have. By properties of long division, we always swap those signs for the bottom one. So now they're positives. And then we can see our negative 3x squared cancels out with our positive 3x squared. Leaving us then with negative 8x plus 17. Now again, we were going to ask ourselves what times x squared gives us negative 8x. There's literally nothing that, I mean, there is something that does that, but nothing really that's going to actually help us in terms of finding the slant asymptotes. And as a result, this would then become our remainder. And so again, back from our definition, we don't really care too much about the remainder. And in class, we'll talk more about like why and how the effect is with the graphs. But for right now, our slant asymptote just comes out to be y is equal to 2x minus 3. And again, this was from the first one. So again, that is example 6 from the 0.2 number 2 set of notes.